Hello, Mr. Yan. Let me introduce myself. I'm Samal Tanakasi Barani. This is my answer explanation for week 10 problems in Teori Sinyal dan Analisis Sistem course in Computer Engineering. I will be explaining three MATLAB scripts that were provided to me. Each scripts represent a different problem, and I will go through them one by one. The first script is for problem one. Let's dive into it. First, okay, let me see the MATLAB first. Um, yeah, I'm reading the scripts in my phone, sorry. First, we define the time range t from 0 to 6 seconds with a step size of 0.01 seconds. And next, we define the impulse response h of t and the output signal y of t. The impulse response h of t is equal to e to the negative t for t greater than or equal to 0. And the output signal y of t is equal to e to the negative t subtracted by 1.5 for t greater than or equal to 1.5. We then define the input signal x of t as direct Dirac impulse approximation at t equals to 1.5. This is done for visual purposes. After defining the signals, we create a figure and plot x of t as a blue dashed line, h of t as red dashed line, and y of t as a solid black line. We also add labels for the x-axis, which is time axis, and y-axis is the amplitude and the title for the plot. Finally, we add legend to identify the different signals and turn on the grid. So this is what it looks like. So after and then I would like to try to compare it to this. I think this that's the solution. Maybe that's close to what it should be, I think. Okay, let me continue. For the second problem, let me copy the script first, the MATLAB scripts. Okay, we start by defining the time range t from 2 to negative 2, sorry, 4 seconds with a step size of 0.01 seconds. The input signal x of t is defined as rectangular pulse of amplitude 2 between negative 1 and 1 seconds. The impulse response h of t is defined as a piecewise function. For t between 0 and 1 seconds, h of t is equal to 2 times t. For t between 1 and 2 seconds, h of t is equal to 2 minus 2 multiplied by t subtracted by 1. We then perform the convolution using this function of x of t and h of t to obtain the output signal y of t. The convolution is done using, sorry, and the result is scaled by the time step 0.01 seconds to get the correct amplitude. Next, we create a time vector type t of y that has the same length as y of t and spans the same time range as the input signals. Finally, we create a plot, yeah, blah blah blah, just like before. X of t blue, h of t red, and y of t is solid black line. And then we add text, signals, and legends. And so this is what it looks like. Uh, the h of t from 0, sorry, from 1 to 2 is from t within 1 and 2 is actually incorrect. So the black line is should be uh should stop from here and go to here actually. But yeah, my equation is wrong. But yeah, I tried my best. Okay, let's move on to the problem number three. We start by defining the time range t from -2 to 2 seconds with a step size of 0.01 seconds. The input signal x of t is defined as a rectangular pulse of amplitude of amplitude 1 between -1 and 1 seconds, and the impulse response h of t is defined as a triangular function between -1 and 1 seconds with a peak of 1 at t is equal to 0. Um, we then discretize the signals x of t and h of t using the array function. This next we perform the convolution and add the plot and blah blah blah, just like the same before. And so this is what it looks like. I didn't have I don't have the blue and the dash line for different colors for different signals just like before because of time limitations. It's 20 to 39 at 15 November. Yeah, I still got one more hour actually, but yeah, that's it. So that's it. I have now explained the three MATLAB scripts provided to me. Uh, if you have any questions, Mr. Yan and friends who are watching this video, uh, or you need further clarification, feel free to ask in the comment sections, or you can contact me privately. That's it. Thank you for watching.